Previously on DNA 101, we talked about this thing called purine and pyrimidine. And we said these were bases and these were structures that you had to memorize because they were very important. The problem, though, is that I kind of made you believe that those two structures will show up every single time. And they do, but the problem is that they are slightly modified. So these are our bases. This is kind of the foundation. If you realized it in the previous video, that's the word that I used. This is the foundation. This is our first component, our first ingredient that we need to talk about when we talk about DNA. And this is a purine and a pyrimidine base. The problem is that DNA uses variations of the purines and pyrimidines. Remember, we talked about tetranucleotide. So tetra meant four. And what we will find out in DNA is that with the heterocyclic bases, there are four of these that DNA uses. And it starts with purine and pyrimidine. And what it does is that it will go through these two structures and it plops on some functional groups. So, for instance, a methyl group. It will plop on a methyl group and it will call it something different. It is a purine or it is a pyrimidine, but it's a special type of purine, a special type of pyrimidine. And there's four of these that we will talk about in DNA. RNA, which we will also discuss, uses a different one. And we will talk about why, and we will talk about why that change happens and how it happens. Okay, so with that said, what are these four purine and pyrimidines that I need to know? What are the four bases of DNA? And we abbreviate those. And what we do is that right? All the way home. I sound like that folktale. Okay, so DNA and nucleic acids, they have G, C, A, and T is what we use. Those are the abbreviations that we use in the DNA world. And the reason that I write them in this order is because as an analytical chemist, what I typically look at is G and C, and I think of gas chromatography. I know that sounds kind of nerdy, but GC typically come together as a pair, and A and T typically comes together as a pair. So think of A and T as your phone bill. We're missing the second T, A-T and T, but it's still A-T, right? So A and T go together as a pair, and GC go together as a pair. We'll talk about what that means a little bit later, but that's why I wrote them in the order that I wrote them. So G and C represent some of the bases of DNA, and A and T represent some bases of DNA. Okay, so what do these represent? So the G is going to stand for guanine. So Guanine. The C is going to stand for cytosine. Cytosine. The A stands for adenine. Adenine. And the T stands for thymine. Thymine. Now, we do have a fifth one, and this fifth one is going to be a U, and that is going to be called uracil. And I'm going to put in parentheses right here beside of this, this is for RNA only. That's it. So G, C, A, and T will be found in DNA. And all of these are found in DNA or RNA as well, except for thymine. And thymine gets replaced by uracil when we discuss the RNA structure. There's a reason. We'll talk about it when that time comes, but there is a purpose in it. Okay, so DNA has guanine, RNA has guanine. DNA has cytosine, RNA has cytosine. DNA has adenine, RNA has adenine. DNA has thymine, but RNA has uracil. So that is where they're different. These are the heterogeneous bases that we will find in these structures. If I look at adenine, this is a purine base. So the basis of adenine is a purine. And we take purine and we add an NH2 group on it, and that makes adenine for us. We'll take a look at the structure in a minute. If I look at guanine, guanine is also a purine. So right up here at the top. And this purine, I add an NH2 to, but I also add a C double bond O to it as well. And this makes guanine, which is a purine, and that is a base that goes in DNA. The cytosine is a pyrimidine. So the cytosine, P-Y-R, I always want to write pyrimidine here, or Pyrimidine. All right, so that is a pyrimidine, and thymine is also a pyrimidine as well. So what you're seeing here is that a purine and pyrimidine are kind of coming hand in hand, and a purine and pyrimidine are coming hand in hand down here. So we have one of each in the couple. It's kind of like male and female, right? So we get this nice couple of G and C, and we get this nice couple of A and T. One's a purine, one's a pyrimidine, but these are the bases that are found in DNA. They are purines and pyrimidines that have been modified. Okay, so what does that mean? Well, let's just quickly take a look at some of these structures of my purines and pyrimidines. So here are my purines. On the left, this is adenine, and on the right, that is guanine. These structures I need you to know because they're that important. So again, the foundation of the two structures are the same. Six-membered, five-membered ring. Six-membered has two nitrogens. Five-membered has two nitrogens. You see the double bonds that are there. None of that changes. The only thing that changes is that adenine has an NH2 group. So adenine has an NH2 group, an amine right here. And then the guanine has the amine in a different location, and it has a double bond O right up here at the top. So that's the difference between the two bases, and both of these are found in DNA. Adenine abbreviated with A, guanine abbreviated with G. So these are my purines. Both of these are found in DNA and RNA. If I take a look at my pyrimidines, I see cytosine, which is on the left, thymine, which is in the center, and uracil, which is the one to the right. Okay, so again, the foundation's the same. It's a six-membered ring with two nitrogens and a double bond. Same here. Same here. Well, cytosine has an NH2 group and a C double bond O. The thymine has a C double bond O, C double bond O, and a methyl group. And the uracil is just like thymine. There's no difference except for the missing methyl group that's right here. Okay, so let's talk about the importance of this methyl group. This methyl group, thymine, is found in DNA only. And the uracil is found in RNA only. And there's a story here. Mother Nature was kind of clever, because what happens is that RNA is destroyed. When RNA is made, it's made for a specific reason. And once that reason has been accomplished, RNA gets destroyed, and it can go back and go through a recycle process. That RNA has to be broken down. At the same time, DNA, which is a very, very close twin to RNA, has to be stable. It cannot be broken down. We want DNA to stay, and we want DNA not to change, and we don't want things to react with DNA, if we can help it. Otherwise, we might turn out like an X-Men mutant. But that might not be so bad sometimes. So Mother Nature takes a look at thymine, or the uracil, I'm sorry. She takes a look at uracil and says, here's a culprit. This is one of the reasons that the RNA is getting broken down. And if I can make this process more difficult, then we can keep DNA behind a little bit longer, and we can prevent DNA from reacting. And what she does is she methylates it. That's all that it requires. So Mother Nature takes uracil, methylates it, puts a methyl group on it at that location. That changes into something that we call thymine, and it's the thymine that is used in the DNA structure. And the presence of that methyl group prevents many enzymes from going in and breaking this polymer chain. The presence of that one little methyl group, that's all that it takes, prevents the enzyme activity from breaking down RNA as it would DNA if that methyl group was not there. Okay, so these are our purines and pyrimidine bases. ATGC, A and T come together, G and C come together. What does that mean? We'll talk about that a little bit later. But basically, this pairing that happens is one purine and one pyrimidine that come along for the marriage. So memorize these structures, know them. There's only slight differences between them. It seems like a lot, but it's not. The foundation is all there. It stays the same. It's just different groups that get placed on them. That's all there is. So if I take a look at these three pyrimidines, well, the only difference between these two is the methyl group. And what makes this one different than the others is that this has an NH2 up here at the top instead of a C double bond O. That's really it, right? So they look like a lot of structures that I've got to memorize, but it's not. It's just modifications of the same structure over and over and over. All right, so there's the story for the 5 bases, A, T, G, C, and then we can throw in U at the end if we're going to talk about RNA. So stay tuned. We're still not really built up to the point about DNA structure yet. This is only a piece of the DNA structure. That's it. So in the next video, we'll continue on with the building block process of the structure of DNA.